Robots are taking over the world! This feels so stupid. Okay, maybe not, but they are taking over the Byte Sized workshop. My name is Zach and I'm the Byte Sized engineer. Today, we're gonna level up our robotics game by diving into the XRP. XRP stands for Experiential Robotics Platform. If you're a student or a hobbyist who's interested in getting into robotics, this is the platform you want to get. Up until this point, if you wanted to build a robotics platform, you kind of had to piece everything together, but all of these industry leaders have come together to make it super easy and to give us all more access to robotics at home. Today, we're gonna go beyond the basics of assembling the XRP, and we're gonna design and build some amazing attachments. Let's get started. Let's see what we got in here. The first thing I see in here is the 3D printed chassis. Then we also have the control board that has the microcontroller on it. So that's gonna plug into the chassis like this. And the cool thing about this, instead of having to assemble everything using screws and screwdrivers and hex keys, everything sort of just snaps into place. The other thing I really like about this platform is that it has these rails along the edges, and I'm gonna be taking advantage of that a little bit later. Okay, what else do we got here? Okay, the battery pack snaps into place just like that. I'm gonna put the wheels onto the motors, and I'm gonna feed the wire through and attach the motor, and it just clicks into place. If you think about it, this kit is like almost like assembling Legos. It's pretty easy. There's step-by-step instructions, and it really doesn't take an engineering degree to put this thing together. Pretty much anybody who has the interest and the tenacity to do something like this should easily be able to pick this up. Oh, I forgot about the casters. And listen to this. They snap into place. They're literally just some plastic balls that roll around. Isn't that cool? The last thing I'm gonna do is attach this servo motor, and I've got some cool plans for this. I'm excited to start designing and building attachments for the XRP, but before I can do that, let's take this thing for a spin. I've got it connected up to my laptop, and I've pulled up the XRP coding environment. Then I went into the example folder, and I just pulled off the installation verification program, and I loaded it onto the microcontroller. What I'm expecting to happen is that the robot will move forward, make some turns, and then come back. I push the button. Let's see if the servo works. Awesome, I've got a lot of ideas on how I'm gonna use that. Now if I push the button again, I'm expecting the robot to start moving. Nice, check that out, it's working perfectly. That means that I didn't mess up the wiring and everything's connected properly. Earlier this year at OpenSauce 2024, I got a chance to use the XRP robot. We got to drive it around a little arena, and there was some 3D printed soccer balls. I even got to play a little bit with Odd J, who also makes content here on the DigiKey channel. This really got me thinking about all the cool things I want to do with the platform, so let's dive in and build the first attachment. After playing with this for a few days, I'm really excited about how easy it is to build attachments for the XRP. On the side of the chassis, there are these rails. All you have to do is 3D print a little clip, and you can attach it anywhere on the perimeter of the robot, which is really cool. The other exciting thing that makes it really easy to build attachments is the control board. Now, so far, all we've connected to it is a servo motor, a distance sensor, and a line following sensor, and then 2 motors. But if you look closely at the control board, you'll see that there are extra ports to add 2 more motors, an additional servo. So the first thing I thought is I want to be able to grab things. So I'm going to design and build a claw for this robot. When I tackle a problem like this, I try to break things down into smaller parts. And so the first thing I did was I needed to design a clip that will attach to the side of the rail. And after a couple of different iterations, I landed on this. This just snaps in from the top and then clips on the side like that. So then I can add and design things around this clip. My first iteration looked like this. It consists of 3 pieces, a left claw, a right claw, and a mounting piece for the servo motor. And the first thing I noticed as I test fit this is that it's a little bit too small. So that brought me to iteration number 2. I changed the dimensions, I printed it out, and now we're gonna test fit this in. Oh yeah, that is so much better. Yeah, I like that so much better, but it seems to be a little bit too loose. So this is kind of a Goldilocks situation. It seems like when I design things like this, my first iteration might be too small, and then I overcompensate, and my second iteration is too big, and then that requires a third iteration where it's just right. So as I go into the computer, I need to make sure that I change those dimensions back into the middle so that that is not so loose. And I really like how this claw attaches now. If you look here, I have a little pin, a post that this is going to snap onto, and now that acts as a little post and a little axis, and I didn't have to use any tools to assemble this. I like how the claw fits on there. I need to make a few adjustments, so let's dive into my 3D modeling software. And then the other thing I need to do is to combine the clip and the servo mount. So let's send this to the printer and we'll find out in 45 minutes whether or not this is gonna work. As you can see, I didn't get it on the third try. It actually took me 5 or 6 iterations of 3D printing, but I think I've landed on something that is gonna work. So let's go ahead and put this thing together. These 3D printed clips are kind of spring-loaded, so as I snap this into place, it should hold the servo tight. Did you hear that? That click was so satisfying. It really holds it in there perfectly. Oh man, that was really good. Again, this should just click into place. Come on, there we go. That is so good. Man, I nailed those tolerances perfectly. I mean, it did take me 6 tries. All right, let's get this thing on the robot and write some code for it. Perfect. All right, I've got XRP code loaded up, and I went ahead and I wrote a simple program in the visual block editor. When I run this program, I should be able to open and close the claws by pressing the user button. So let's go ahead and run it. Check that out. That's so cool. I think this is a wonderful first iteration of building a claw. It works. I can add 2 claws on there and control them independently because I have 2 servo connectors on the control board. But I think there is something missing with this claw design. As I open and close these claws, you'll notice that they kind of close at an angle. These would work much better if I were able to open and close the jaws and make them parallel instead of opening and closing at an angle like these do. So in order to do that, I need to implement what's called a 4-bar linkage. That is a mechanical linkage that uses 4 links, surprisingly enough, to achieve a parallelogram, and that will allow these claws to open and close in a parallel way. So let me design that on the computer and print out a first prototype. I just pulled these pieces off the 3D printer and I'm excited to see if they work. So to get started, let's put together the base part. So on the earlier versions of this, I actually had the clip and the attachment part as one piece and they clipped onto the robot chassis, but I decided moving forward that it would be smarter to actually separate these 2 pieces, and I added a little dovetail clip that will slide the pieces together. So that way, if I ever make any changes, I don't have to reprint the whole piece. I can just print the part that I need, and also it allows me to develop further attachments in the future that will just slide on using the dovetail system. I changed the way how I did the clip on this one because I thought it might be better, but it seems to be a little bit harder to get in. Oh, there we go. Did you hear that click? That's good. All right, that works great. All right, so the next piece that I'm gonna put on is the servo gear, and that has a little servo arm that goes in here. Okay, and then I use the screw to hold it in place. Good. I like that. The next piece I need to put in is the other gear, and this one just snaps into place. Hopefully I don't break this. One thing to note about using carbon fiber filaments is that they are actually kind of brittle. Really, what you could do is just print it in another filament like PETG or PLA. This one's not going on, so rather than risk breaking something, I'm gonna remove the first gear, just give myself a little more room to work with. Now I can snap this on without worrying about breaking it. There we go. Yeah, once it's on, it works fine. It's just getting on there is a little bit tight. Now I can put that first gear back on and make sure the angle is correct. The next pieces are the claws, and they are just mirror images of each other, and all I need to do is kind of snap them into place. That just snapped off. Why is this so difficult? How can I design this or improve the model so that I don't have these little pieces snap off? I tried adding as much extra material around it as I could, but they're just so small and the assembly just puts too much pressure on them and they keep breaking off. So, all right, back to the 3D model. I gotta figure this out. Okay, so that broke, and rather than going into the 3D model and trying to fix it and reprinting another piece, my goal here is just to see if this works. I need to keep moving forward, so I'm gonna drill a hole into this piece and use a machine screw. Yes, I know that I said that I was aiming for a tool-free assembly, but like I said, I need to figure out if this works first. Now, I'm going to grab an M4 machine screw, and it just so happens to be printed in the same color container. So I'm not even going to use a tap. I'm just going to use the threads on the screw to tap into this plastic. I've done this lots of times and it seems to work great. I'll leave enough open that this can still rotate. Okay, yeah, that is going to work so much better. Maybe I need to not worry about making this a tool-free assembly because using that screw is going to give me a much better joint. So I'm going to keep assembling this, and if anything else breaks, I'm just going to drill more holes and use more screws. There we go. All right, that one seems to be working. Oh, these actually go this way. Did I put those on wrong? No! I put those on wrong. I put those on the wrong one. So I need to take that off. Okay, we'll try that again. Much better. I got them on the right way. So there's just one final piece, which is the last link that makes this a 4-bar linkage. That just broke. It's just not worth all of the extra futzing around with this to get it to work. So I'm just gonna drill some holes and put in some M4 screws just to make sure that this works. As I'm attaching this to the chassis, I'm realizing that it's running into the line following and the range finding sensor. And so I'm thinking to fix that problem, I'm gonna move this thing actually a little bit forward and really lean into that look of making it look like a crab. I've got the same program running that I had before, and all I need to do is press the user button and we'll see if this works. It works. Ah! No, I'm just kidding. That didn't actually hurt. Getting better at acting, aren't I?
Yeah, I know, you're getting much better.
Do I need like an agent now? Like, how does this work?
Yeah.
Cool. So in addition to moving the claw forward, I think I also have another way to improve it. I want to add a second degree of freedom with a second servo so that the claw can rotate in addition to opening and closing, just like your hand and wrist would work. So let me jump back on the computer and do some more design work and print out the final version of the gripping claw. As you can see, I've had a really busy weekend. My task was to design a way to mount these claws a little bit more forward on the chassis. I also needed to come up with a way to rotate the claw like a wrist joint. The first piece I designed is this one, and it slides over the caster wheel. If you look on the front, I have a little dovetail joint here, and the goal is that I want all of these pieces to be interchangeable. I want to be able to mount the claws anywhere on the chassis, including up front. So everything I designed has that mating dovetail joint. Now that I can mount the gripping claws up front, here's what I came up with for the rotating wrist. I designed this little piece that accepts another servo, and the servo kind of clips into place just like this. I wanted to make sure that the second servo was out of the way, so when I designed this mount, I made sure that it was kind of above and behind where the claw goes, so that it kind of fits above here like this and slides on just like that. Before I can attach the claw, I need to assemble the rotating dovetail piece. This piece just attaches to the servo, and once I screw it on, it will rotate around with the servo. To attach this rotating dovetail piece, I'm just going to use the servo horn that came with the servo. All right, I think that's working. Now I can add the claw. And if you remember, I had so much trouble with all of those little parts breaking off. On this one, I just ended up using all M4 screws, and look how much better this works. It's so much smoother and nothing's breaking. So I am glad that I made that switch. And if you look at the other side, you'll notice that I added that sliding dovetail so that I can attach it to that rotating arm. That's gonna be so cool. Okay, all right, let's plug this in and head over to the computer and write some code to see if it's gonna work. I've got a basic demo here that I wrote in the block language, but now we're ready to see it in action. So I just need something, what can I grab for it to pick up? Oh, perfect. My son was in over the weekend and he was playing with this little red car. All right, let's see if this can grab the red car. I hit run. Yes, I have it turned on. Nice. I want to incorporate everything that we've done so far. So here's the plan. We've set up a little bit of a simulation here where the robot is going to dispose of some hazardous materials. The robot will roll up to the station, grab the hazardous material, turn around, and bring it over to the disposal site. But the problem with the disposal site is that it has a narrow gap. Fortunately, we have a wrist on our robot so it can twist and drop the hazmat right into the disposal station. That's the plan. Let's see if I can do all of this. I've been working on writing a simple program, and here's what should happen. The robot should turn to the right, and then it starts moving forward. When it gets to about 7.5 centimeters, which I measured with the ruler here, it'll stop, and that's where it'll close the gripping claw onto the hazardous material. From there, the robot should back up and then make a turn over here to the left. And then as it moves forward, it's reading that distance sensor again. And when the distance sensor reads about 12 centimeters, it'll stop. And then it will rotate the claw. And as it pulls forward, it should drop that hazardous material into the storage facility. That's what's supposed to happen, but we'll see what actually happens once I press the button. One thing I want to mention here is the weight that you see on the back left corner. As I was doing my testing, I noticed that the left wheel was sort of slipping. At first, I thought that it was off balance because of all the weight that I added using the gripping claw, but upon closer inspection, I noticed that the chassis is actually warped a little bit and it lifts the back wheel off. So the solution was pretty simple. I just added a little bit of ballast weight on there to make sure that that wheel gets enough grip. Let's give this a shot. I press the button and it's off. Okay, good. It turned 90 degrees. Oh no, it missed the hazardous material. Let's see if the rest of the program works. Okay, good. It makes its turn to the other way. And it's sort of heading off in the wrong direction. Okay, so we need to make a couple of adjustments. Let's try for a second attempt. All right, good. You're making the turn. Stop. All right, good. Move forward. No, what are you doing? That's hazardous material. Don't knock it over. It needs to move a little bit forward as it reaches the hazardous materials. It seems like it's turning a little bit. I wonder if I can adjust the speed of the wheels to make it go a little bit straighter. Okay, it's turning 90 degrees. Good, looking good. All right, pick up that hazardous material. Awesome. Okay, now turn around and go that way. That's where the storage container is. Good. All right, stop. Okay, a little too far. All right, straighten out, straighten out. Good, 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 good. Stop. Oh, we're so close! I'm not sure why this didn't work perfectly. I'm realizing that there's a lot of factors here. If I feel the surface of my workbench, it's not very flat. I'm also relying on the internal measurement unit, the IMU, to tell me when it's reached 90 degrees. And I'm realizing that if I really want precision here, I think I need to use the line following sensor on the XRP. So I'm gonna give it one more shot to see if we can get the hazardous material in there. And if that doesn't work, then we're gonna start putting tape down and using the line following sensor. Here it goes. It's making the turn. All right, now stop at 90 degrees. All right, not bad. All right, go ahead, go forward. Now stop. Yeah, we did it! Awesome! That was so cool. Everything that we worked on came together and we disposed of the hazardous material. Everything that you saw me build in this video will be available to download for free. Check this out. We've got the basic gripping claw. That's the one that just opens and closes like this. We also have the parallel gripping claw that uses the 4-bar linkage, and then we have the rotating gripping claw. You can go and download and print these out yourself. Also, I'm really curious, what would you build? Let me know down in the comments. That's my favorite thing about the XRP platform, is that you can just build attachments for it like this. In fact, this is the box of all of the rejects and failed prints that it took to get to this point. If you notice, I used a lot of time-lapse videos to show these 3D prints. And if you're interested in modifying your 3D printer to take time lapses, I made another video here on the DigiKey YouTube channel that goes over that whole process.